All right, welcome class. Today we are going to start with talking about moving into our exponential unit. This is unit 3. So what I'll do is I'll leave this on the screen for about 3 to 5 minutes. What I want you to do is I want you to actually go through and I want you to see if you can come up with the answers to these. When those answers, when you feel like you have the answer, I'll be back on Tuesday. So please take this time to just work with your partner to figure out the answer, and then save them for me, and we'll discuss these on Tuesday. All right. So the sub should have given you a handout entitled "Exponential Equations G Sequences Notes." This is the handout that we'll be using for today for your notes, and you can also use that for your homework slash classwork assignment. So when we're talking about geometric sequences, a geometric sequence is a sequence of terms that have a common ratio between them. When we're talking about an explicit formula for a geometric sequence, and remember we actually did explicit formulas for arithmetic sequence as well, formulas used to find the nth term of a sequence. So just like with the arithmetic sequence, we were trying to figure out how we can find the term in the 15th spot. We can do the same thing for geometric sequences. We can try and find the term that's in the 15th spot. So when we're talking about a explicit formula for a geometric sequence, you see it's a sub n equals a sub 1 times r to the n minus 1 power. So remember that a sub n stands for the term that we're trying to find, the position of that term or the actual term itself. The a sub 1, that means the first term in the sequence that you're given. And then the R stands for a common ratio, very similar to common difference in arithmetic sequence. So, and also make sure that you are filling out your notes with these. When we're talking about a recursive formula for a geometric sequence, is when we're trying to find the a sub 1 and we're given the formula. So the formula still stays the same, with the exception of now we're talking about a sub n minus 1 instead of a to the n minus 1, where a sub 1 is the first term in the sequence and r is the common ratio. But we're going to look at a couple of examples so that you can see exactly what that means. First one says find the common ratio for 8, 16, 32. So when we're trying to find the common ratio of a geometric sequence, what we do is we actually take the the next term and divide it by the previous term. So for example, in order for, if we think that this is a geometric sequence, meaning are we multiplying or dividing by the same amount every time, then what we can do is we can take this a sub 2 term, which in this case is 8, and divide it by 4. Well, we know that when we do 8 divided by 4, that gives us a common ratio of 2. Or we could do 16 divided by 8. Or we could do 32 divided by 16. Regardless of which group you use, whether you do a sub 2 divided by a sub 1, a sub 3 divided by a sub 2, and so on, your common ratio should still come out to be the same every time. If it does not, you either did an arithmetic, either did some algebra wrong, or it's not a geometric sequence. But in our case, we see that R equals 2, which is our common ratio. And so now, what we could actually do, if we wanted to figure out, well, what number is in the 15th spot, then what we could actually do is we could actually take our 4 and say that this, and if we plug it into our formula, we could say, okay, well, 4, we have our common ratio, and I'm trying to write with the computer, so please forgive me for that. We have our 2. And since we're trying to find the term that's in the 15th spot, we will actually do 15 minus 1 as our in our exponent spot, which we know really just means 4 times 2 to the 14th power. Right? But if we were to plug this in, we will actually see what this is saying. This is actually saying, well, what term is in the 15th? It's in the 15th spot, and so we can actually figure out what that is. Right? Let's look at the next one. I give you a minute or so to figure out what is the common ratio. So hopefully you saw that you could do 64 divided by 256, because remember, 64, and we're dividing that by a sub 1. Now you also need to remember, like, 16 divided by 64. Or we could have done 4 divided by 16. Either way, you'll see that your answer should come out to be 1/4. So that's our common ratio. Let's look at this example. This example says that we want to find the common ratio, the explicit formula, and the 7th term. So remember, in order to find the common ratio, we take the second term, which in this case would be our 3, and divide it by the first term, which is 6. I'll give you a couple of minutes to just figure out what the common, I'm going to give you 1 minute, excuse me, to figure out what the common ratio is. All right, so you should have gotten the common ratio to be 1/2 or 0.5. But now we want to figure out what the explicit formula is. So when we do the explicit formula, notice that we're just going to substitute in the things that we know or that we found. Well, we don't know what term we're trying to find in this case because we're dealing with the explicit formula. But we do know what the a sub 1 is. And we know that the a sub 1 right here is 6. Isn't that right, Mr. BB? Well, we also know that our common ratio is 0.5 or 1/2. The explicit formula says that we can write it as it is right here. The a sub 1 times the common ratio. We don't put anything in the place of n, and we just keep this as a sub n. So this is our explicit formula. This formula right here can be used to find any term in any spot. But now the next part says they want us to find the 7th term. Right? And so when we're talking about finding the 7th term, what we're saying is we are actually going to take our 7, our a sub 7, excuse me, because we're trying to find the term in the 7th spot. We're going to keep this 1/2 or 0.5, whichever way you want to write it. But now we're going to do the 7 minus 1 in the parentheses, in the exponent. So in your calculator, you actually would write it as 6 parentheses 1/2 and then you put to the 6th power because 7 minus 1 is 6. So this is going to tell us what's in our 7th spot, and we know that the term that's in the 7th spot actually comes out to be 0.094. 0.094. Let's look at one more. See if you can find the common ratio, the explicit formula, and the 10th term. So hopefully you found your common ratio to be 3. Hopefully you found the explicit formula to be -4 parentheses 3 to the n minus 1. And Ms. Waddy, tell us what our answer is for this problem. What term is in the 10th position? So hopefully her answer is correct. You should have gotten a sub 10 is equal to -78,732. So what we just completed some examples dealing with explicit formulas and common ratios and finding terms in certain positions. All right, let's look at a word problem. The 5th term is 1792. The common ratio is 4. Write the explicit formula for it. And give you a minute or so to work with that. The a sub 5, which is the fifth number in the fifth position, is 1792. Hopefully you also saw that your n is equal to 5 because that's the term that we're, the position that we are given. So with all of those factors being given to us, we can plug into the formula as is. We don't know what a sub 1 is. So that's something that we will actually have to find. Because remember, in order for you to write the explicit formula, you have to have the a sub 1. Well, some people may be wondering, well, Mr. Collier, how do we find the a sub 1 to be 7? So in order to find the a sub 1, what we had to do is once we completed this step right here, that step right there said that we had 1792 equals, now remember this actually comes out to be 4 to the 4th power. So it's really like saying 4 to the 4th power is 256 a sub 1. And so now what we did was we divided both sides by 256. And 1792 divided by 256 should come up to give you the answer that we want. Right? Should come up to give you the answer that we want. Let me check mine right quick. 1792 divided by 256. That gives you 7. So now you see how we end up with 7. But we needed the a sub 1, so therefore that's why our explicit formula is what you see right here. So I want you to work on this one. I'll give you a few minutes to work on this one. All right, it says during the month of October, a few teachers decided to spread some holiday fun by starting a game of co-ed boo-ed. Yes, whatever. On the first day, 3 teachers were given boo bags and directions to boo 2 other teachers. If every teacher followed the directions to two boo bags, 2 teachers, with candy and a sign, find the following. Well, what would be the explicit formula for this? So remember, when we're dealing with the explicit formula, we're basically saying that we need to know the a sub 1, we need to know the common ratio. Right? Well, when we look at this, we see that in this case, our ace of 1 is 3, because it tells us that on the first day, 3 teachers were given boo bags. Our common ratio is 2, because it says that, right, it says that 2 teachers were given boo bags and directions to boo 2 other teachers. So every time they were booing 2 teachers. So with those things being given, we should be able to figure out that our explicit formula is 3 parentheses 2 to the n minus 1. But now we want to find out what the first 4 terms are. Well, we already know what term number 1 is. We know term number 1 is 3. Now, sometimes it can be pretty easy to figure out what they are, especially in this case, because since our first term is 3 and our common ratio is 2, that means that we're multiplying by 2 every time. So that means we start off with 3, times 2 is 6, times 2 is 12, times 2 is 24. Well, think about this. What would be the 20th fact, the 20th term? Right? Could you figure out the 20th term from the explicit formula? You should be able to. So this is what we've done for geometric sequences. Sub, if you don't mind, the person that's standing in for me, can you hand out the homework classwork paper? Class, I do want you to understand that the assignment that you're receiving today will count as a classwork and a homework grade. Feel free to work together with each other, but please do not be disrespectful or get loud. And make sure you have that paper for me tomorrow upon my return. Thanks.